Hi everyone, thanks for attending this session. So today I would like to talk to you about how to provision hardware for running ML experiments in a better manner on GCP. And also just to get an idea of my audience, how many of you are into ML with GCP, using GCP for ML stuff? Okay, fair mix, seems like a fair mix. And how many of you are using Vertex AI for this purpose? Vertex AI, anyone? Cool. Uh, I forgot to take my slide changer. Sorry about it, but that's okay. All right. Here's a bit about myself. I'm an incoming developer advocate at a company called Hugging Face. Previously, I was at an Australian startup called Carded. There, I used to deal with a lot of text and HTML data. So that's about me. So also just as a disclaimer, this is not my sole work. I am presenting this work on behalf of my ex-colleagues, Neil Abro and Shane, and of course, myself. And here's a rough agenda of what's about to come. We will start off by discussing the traditional and the typical workflow of provisioning instances for running ML experiments. And then we'll try to dissect the problems typically involved in such a workflow. And then we'll get to the meat of the talk, where we will sort of discuss how we can better streamline this workflow with something called Terraform. And then we'll conclude with a demo. Yeah. So let's start with the standard workflow. And as with most of the other services on GCP, Vertex AI, provides you with a graphical user interface that sort of follows a point and click kind of a workflow. But before we go to the Vertex AI part, let's quickly discuss the main components of running an ML experiment. So you would want a pre-configured environment where you have all the dependencies and the CUDA stuff sorted out. Then you will probably want a notebook instance for better engagement and interactivity across the different modules. And then you'll probably need access to TPUs and GPUs if you are into running compute-intensive stuff. And optionally, you would also want a central storage bucket to sort of serialize your experimentation artifacts. And Vertex AI Workbench instance, which is a managed service provided by Google Cloud Platform, lets you provision a notebook instance just with a few clicks. It offers you with a graphical user interface, and it comes with most of the things already configured. So as you can see on the screenshots here, you just select and specify a few things, and boom, you are up and running just within 2 or 3 minutes. And similarly, if you also want to provision a Google Cloud storage bucket, then also it again involves, it consists of a few clicks. It's just that. Now, this is pretty straightforward, right? Now, you might be wondering what could be problematic in this straightforward workflow. Now, let's try to dissect it. Now, the problem here is in repeatability and lack of reusability. Every time you try to create a new instance, the same steps are being repeated. And what if you miss out on a particular step? Now, for our case, we are just trying to provision a notebook instance and a bucket on GCS. What if there are other resources that you want to provision for running your ML experiments, right? It's easy to miss out a particular step. And this also has a direct impact on the resource cleanup side, right? What if you forget to clean one resources, which can, and you forget to clean that one resource up, and you are basically doomed for life. It can lead to unnecessary costs and all that. So basically, the point I'm trying to make here is, this typical workflow, the point and click workflow, does not give you any reusability. It does not enforce any version control or whatever. There has to be a better way, right? And now I'm going to sort of shamelessly read out a quote from Terraform. It says, provisioning infrastructure through point-and-click graphical user interfaces or custom scripts is slow, error-prone, inefficient, and does not scale. Basically, it sums up everything that I wanted to say about the point-and-click workflow that is typically used for hardware provisioning. So yeah. Now, additionally, you also might need to install custom Python dependency and also custom system-level packages. Additionally, you also might need metadata scripts or startup scripts to better control your notebook instances. Now, I really hope I could convince you why point-and-click way of provisioning hardware isn't the most suitable way when you are especially working in a distributed team. Uh, yeah, cool. So with that in mind, let me introduce Terraform to you and how it can help us tackle some of the challenges. Again, a shameless readout. I'll keep this slide on for about 20 seconds, just so you can read it. So to sort of the long story cut short here is Terraform helps you to provision and treat infrastructure as a code so that you can eliminate any redundancy, any repeatability across the different steps that might be needed to provision hardware effectively and reliably. Cool. So with Terraform, you are going to realize the same exact steps involved in your workflow, but with code. And the code will include defining a set of variables, such as resource names, GPU types, machine types, and so on, and specification of what resources you wish to sort of provision on Google Cloud. And optionally, you can also add a startup script to your notebook instance resource. We'll get to that in a moment. Now, let's start with the basic structure of your Terraform code. You start by defining all your hardware-related variables in a script called variables.tf, and tf stands for the Terraform extension. And then you specify what resources are going to be provisioned in a script called main.tf. You can name the scripts in any way you want, but naming certain things in a certain way, I think, helps you achieve a sense of idiomaticness and also a structure. And optionally, if you have any scripts, metadata scripts or startup scripts, you can keep them under a directory called scripts, and then you can also use those scripts inside from the main.tf scripts. All right. Now here's how here's how you could put all the content inside the variables.tf script. You would start by defining all your GCP related stuff, the project name, the region, and also the zone. And then the rest of the steps basically depend on the kind of resources that you want to provision. In our case, it's just a notebook instance and a bucket on GCP. And the code for all this, by the way, look much simpler than you may think. So yeah, the usual GCP stuff. Let's start with the variables.tf script. It's the usual GCP stuff, the project ID, the location, and the region. And then you have got your notebook instance. You start by defining the notebook's name, the machine type, GPU type, and all that. And then, again, a couple of GCS-related stuff. And as you can see, it has got a nice sequence. So you start by defining the general GCP-related stuff. Then you get to all the resources that you want to provision. Again, in our case, we have got a notebook instance and also a GCS bucket. Now, within the main file, you basically start by specifying what resources you are going to follow, what resources you are going to provision. So we start with the usual GCP stuff, as usual. And then we get to the notebook part, where we define machine type, location, GPUs, and all that. And then we get to the specifics of the notebook instance. For example, the kind of GPU that we want to use, how many GPU accelerators that we want to use, and so on. And of course, for brevity, I have cut down some parts, but I hope you understand. And then, yeah, and other things might include whether or not we are interested in installing the GPU drivers. Of course, we are interested in installing the GPU drivers. No one wants to sort of sort out the CUDA stuff on their own. At least I do not know of any. And then we can specify what's the boot disk size, what's the data disk size, and so on. And as usual, we conclude with the GCS-related stuff. And as I was mentioning, for brevity, I have cut down certain parts like subnetwork, networks, and so on. And here you can also specify a couple of additional things, as I was mentioning at the beginning, like startup scripts or metadata scripts. So I like to really control the CPU utilization of my instances. Specifically, I want a script that can monitor my CPU utilization over a period of time. And if it falls below a certain threshold, it will just basically automatically shut down the notebook instance. That can save me a ton of money, right? But if you have got a custom, Docker container which you would like to mount in your notebook instance, then it's also sort of possible. You just need to specify the container image resource within your main.tf Terraform script. Cool. They told me I have got only 15 minutes left, which is fine. And if you are working in a distributed and remote team, you can optionally store the intermediate Terraform scripts, which enforces better concurrency and better collaboration. Cool. Now, before we get to the demo part, let's tackle this elephant. Let's get to this comparison. Why are we not using shell scripts for this purpose? That's because shell scripts do not understand the state. And with Terraform, you get a sense of states, right? Because it understands what resources have been successfully provisioned and what resources got failed during the provision stage. And it also gives you a better control over the entire life cycle of your infrastructure management workflow. And of course, since we are doing things using code bases, version control comes by default with that. Cool. Let's get to the demo part. Can we have the screen for demo? Can we have the screen for demo? It's there? Cool. Thank you. So what I'm going to do here is I'm going to clone the accompanying repository for this talk. By the way, I'm going to share the resources just after my talk ends, so don't worry about it. I'm going to clone the accompanying repository. All right, it's cloned. I'm going to navigate to the directory. I'm going to use my favorite code editor to open the directory, which is VS Code. So I guess we are already here. Oh, all right. Cool. I'm going to navigate to the Terraform directory. I'm going to open the vars.tf file. I'm going to zoom in a bit. OK, we can see everything. I'm going to change my GCP project name, Fast AI Exploration. It's a very childish name, I know, which is OK. I'm going to rename my notebook instance name and also the GCS bucket name. So let me quickly walk you through the script so that you have an understanding. So we are basically starting off with the usual GCP stuff, all the variables that are needed to sort of provision your hardware resources effectively. Then we are getting to the notebook instance part, where we are basically specifying the GPU type, the GPU count, what image family to use, and whatnot. And then we are finally concluding with the GCS-related stuff. And yeah, I mean, we need to also specify which network and which subnetwork to use, but we can skip that part for now. Now, that's all that we need to know. By the way, if you have already sort of configured the GCP authentication and authorization locally or on any other environment, you can directly clone this repository and get started, provided you have got all the services and the APIs enabled. Let me switch back to my terminal, navigate to the Terraform directory, run Terraform init. Terraform has been successfully initialized. Terraform plan. So it's calculating what resources it's going to provision. So as we can see, it's going to add or provision 2 resources, which is a notebook instance and a bucket on Google Cloud Storage. Now that's done, we can actually start the provisioning workflow. So Terraform apply auto approve. And as you might already know, provisioning or spinning up a bucket instance on GCS is not that time consuming, but spinning up notebook instances or virtual machine instances that have got GPUs and all the other custom dependencies, they take time. So while that's chugging up, what I have done here is I have created a notebook instance following the same workflow so that we can quickly skip to the demo part. And yeah, you just need to take my word for it, because I have actually done that. So ML-NB is the notebook that I had provisioned using the same workflow. So after our notebook instance has been provisioned, we would want to validate a couple of things, right? For example, whether or not the CUDA stuff is already sorted out for us, whether the custom Conva environment that we wanted the startup script to create for us, whether that got created or not, and also the CPU utilization stuff, right? I forgot to show you the startup script that I have also attached to the notebook instance. Let me quickly show that. So I am also attaching this particular startup script to the notebook instance, which, by the way, you can also do from the graphical user interface. It's basically creating a custom Conda environment with Python 3.8. It's also configuring a bunch of Git stuff. And then we are getting to the CPU utilization part where it will automatically turn off the instance if the CPU utilization goes below a certain threshold. So that's all about the startup script. And here's a brief rundown of the main.tf file, where we are basically inheriting all the values from our variables.tf file. And we are just specifying how the resources should be provisioned and what resources exactly should be provisioned. So that's it. And I'll let it load. We just need to wait for the notebook to get successfully switched on. So that's that. And meanwhile, let me refresh the GCS bucket console. And ML bucket Terraform Sayak, this is the bucket that I had instructed Terraform to create for me just now. So that has been successfully created. Let's see what's going on here. I have got, OK, 8 minutes. Yeah, GCP folks, maybe you want to improve the hardware switch on timing. So it's kind of slow. It gets frustrating at point in times. So we just need to sort of wait. Again, just to give you another context, after your hardware resource, in our case, which is a notebook instance, has been successfully provisioned, you would want to sort of validate and verify a couple of things, like we showed in the startup script. We had asked Terraform to create a custom Conda environment for us with Python 3.8. We would want to verify it. Of course, the CUDA stuff, whether or not it has been sorted out for us, and then the CPU utilization part. So for that, we are going to use the serial output of the notebook instance that is just about to get provisioned. So these are the things that we are going to validate. So not sure why it has not been switched on yet. Oh, OK. OK. It's switched on. Cool. Again, we'll have to wait for a while. I think not more than 2-3 minutes. Cool. All right. It's there. So the first comment that I'm going to run here is NVIDIA SMI to check if the CUDA stuff is sorted out. All right, we can access the GPU, and CUDA seems to be doing just fine. And then Conda env list, the custom Conda environment, which is Py38, which is exactly what we had specified in the startup script. So Py38, that's there. And then we also need to check the serial outputs to know if the CPU utilization stuff is working as we had expected. I'm going to also copy the notebook instance name. Yes, I meant that. All right, cool. Let me do it once again. All right, it's taking time to reload, but that's fine. I'm going to just keep doing it. I've got 5 minutes of time, so that's fine. One more, I guess. Gonna copy it. Oh, I guess it got shut down automatically. Is it? No, it's there. OK, let me refresh it once again. Whew. Oh, cool, it's there. Yeah, so probably the startup script is taking time to sort of get reflected. But here in somewhere down the serial logs, you will see the total CPU utilization that has been captured by the startup script. So yeah, it usually takes a bit of time to get reflected. But yeah, you get the idea. Let me try it for one last time. Oh, OK. Now we can see. So the machine is already in use, resetting counter to 0, and the idle minutes count is 0. So we have got successful validation now. Can we get back to the slides, please? All right. So just to wrap up my session, we sort of took a short look into why the point and click workflow of provisioning hardware is bad business, especially when you are running ML experiments at scale and also in a distributed team manner, and how we can improve that workflow by using the right set of tools in a codified manner. And thanks for being such a great audience. And I would like to leave you with a short link in case you want to refer to the materials that I presented today. It includes the slides, it includes the code, and also a short demo in case you need to refer to it. And thank you.